Okay, this black goo called crude oil doesn't look like much, but it's basically the raw recipe for almost
Everything that powers our world, from jet fuel to gas in your car, even plastics. Today, I'm going to show you how engines transform this messy soup of hydrocarbon into useful fuels inside refinery.
Let's start at step 1, how crude even gets inside a refinery. Crude oil arrives by ship, by line or even rail, and the very first thing engineers do is to remove water, sand and salts. Imagine filtering out dirt before cooking. This desalting step protects the refinery's machine from corrosion. Because trust me, if salt sneaks in, multi-million-dollar equipment could rust like cheap bike in the rain. Now it's clean enough, so let's start cooking this stuff. The heart of refinery? A tower called the distillation column. Think of it like the world's biggest cooking pot, except 60 meters tall. We heat up crude up to 350 to 400 Celsius, and the vapors rise inside the tower. The lighter stuff, the LPGs, floats to the top while heavy goo like asphalt drips down to the bottom. It's literally oil cooking class, layer by layer. But not everything comes out perfectly. Some molecules need extra engineering magic. Crude oil naturally has too many heavy molecules we don't need. So engineers use a process called cracking, literally. Breaking big hydrocarbons into smaller, useful ones. It's like taking Lego blocks apart to build something new. This is how we turn heavy oil into gasoline, jet fuel, and diesel. Without cracking, we'd be wasting half the barrel. But cracking alone isn't enough. We also rearrange molecules. Sometimes molecules are the right size, but the wrong shape. So we use a process like reforming and isomerization to rearrange atoms. Why? To make fuels burn cleaner and more efficiently in engines. It's like giving hydrocarbon a makeover. Some ingredients just styled differently for performance. Now that the molecules are tuned up, but fuel also needs to meet super strict safety standards. Gasoline from the refinery isn't readily available for your car. We add additives to control knocking, improve stabilities, and reduce emissions. Diesel also needs to be treated to remove sulfur, because sulfur equals to acid rain. Engineers spend huge effort making sure fuels not only power engines, but also meet environmental rules. Speaking of engines, let's see where each fuel actually goes. For 1 barrel of crude oil, you get a buffet: gasoline for cars, diesel for trucks, jet fuel for engines, and LPG for homes. And even asphalts for home. Engineers carefully balance how much each product to make, depending on demand. In summer, people want more gasoline. In winter, more heating oil. A refinery is basically a giant fuel factory responding to the world's needs. But behind the science, there's almost massive safety at play. You've got heat, pressure, flammable fuels, basically a recipe for disaster if not handled carefully. That is why refineries are packed with safety systems, fireproof walls, emergency shutdowns, and gas detection, and teams running safety drills weekly. Engineers design for what if scenarios constantly, because when you are dealing with explosive fuels, safety is engineering's number one priority. Now, the fun part. Let's zoom out to see the bigger picture. Beyond fuels, refineries also make the building blocks for plastic, fertilizers, and the chemicals that shape modern life. But they also contribute to emissions, so engineers are now designing green refineries that blend renewable feedstocks like vegetable oils into the mix. It's the same engineering challenge, but pushing us towards a cleaner future. So, the next time you see a plane taking off or drive a car, remember, it's all started with a black hole, engineering, and a whole lot of science.